Talking about similar right triangles, recall that corresponding sides of similar triangles are in proportion. This tells us that the ratio of the lengths of any two sides in a right triangle will be equal in similar triangles regardless of their sizes. So consider the following two right triangles. We have the 3, 4, 5, 15, 20, 25. In both triangles, the measures of angle A is the same. Angle A in both cases are the same ratio. Because these are similar triangles, the ratio of the legs across from angle A is called the opposite over the leg next to the angle, which is called the adjacent to angle A, is the same in both triangles. So with respect to the angle A that we're talking about, the 15 would be considered to be the opposite side or the opposite leg. The 20 would be the adjacent side or the adjacent leg, and the 25 would always be the hypotenuse. Same thing for the smaller triangle. The 3 is the opposite to angle A. 4 is going to be adjacent to angle A. And the 5 is going to be a hypotenuse. Now, if we're talking about angle B, it is different. Okay, so it all depends on what angle you're trying to refer it to. The ratio of the acute angle's opposite sides lengths divided by its adjacent side length is so useful that it has been given a special name called tangent. We write it as tan of the angle A, which is the opposite side, divided by the adjacent side. This is our first trigonometric ratio. There are 5 others we could form. Relative to an acute angle in a right triangle, there are 6 possible side over side ratios. Opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, adjacent over opposite, hypotenuse over opposite, and hypotenuse over adjacent. Since the last 3 ratios are the reciprocals of the first 3, we will only use the first 3 ratios. We have a special name for these ratios and use them to find unknown sides and unknown angles in a right triangle. For an acute angle A in a right triangle, we define and denote the tangent, sine, and cosine of angle A as follows. So again, with respect to angle A, side A would be the opposite, side B would be the adjacent, and side C would be the hypotenuse. So with respect to angle A, tangent is going to be the opposite over adjacent. Sine of angle A is going to be the opposite over the hypotenuse. Cosine is going to be the adjacent side over the hypotenuse with respect to angle A. One saying that might help you remember these trig ratios is the saying SOHCAHTOA, SOHCAHTOA, and that is the sine of the angle is opposite over hypotenuse. Cosine of the angle is adjacent over hypotenuse. And tangent of the angle is opposite over adjacent. Important notes: the trig ratio definitions never change. However, if we want to find the tangent, sine, and cosine of other acute angles with respect to angle B, the labeling in the right triangles change. That means the side opposite B and the side adjacent to B are reversed of what they are relative to angle A. So again, now we have with respect to angle B, which means that this side, B, is now opposite. The adjacent side is now A, but the hypotenuse is always going to be C. But it's still tangent of an angle is opposite over adjacent. Sine of angle B is opposite over hypotenuse, and cosine of the angle is adjacent over hypotenuse. That will never change. Find the value of the sine, cosine, and tangent of the acute angle A. Now here they give you all 3 sides. So with respect to angle A, 12 is going to be your opposite. 5 is going to be your adjacent. And 13 is going to be your hypotenuse. Now, one thing we haven't really clarified is what do we mean by opposite? It is a side that is not used to help form the angle A. So what sides are used to help form angle A? Sides B and C. So side A would be the opposite. What does adjacent mean? It is the side along with the hypotenuse that helps form that angle. So angle A is helped formed by side B and the hypotenuse, so that means that side B is the adjacent. So sine is going to be opposite over hypotenuse, and that is going to be A over C. Cosine of angle A is going to be adjacent over hypotenuse, which in this case is B over C. And tangent is going to be opposite over adjacent, which is going to be A over B. A couple of things I want you to realize whenever you're looking for or trying to talk about sine of an angle or cosine of an angle. Notice that in sine of angle A, the answer is 0.9231, and cosine of angle A is 0.3846. The one thing I notice about both of them is that the sine of the angle will be less than 1. That is a trademark of that definition because your denominator has to be bigger than the numerator, which means that the value must be less than 1. Now when it comes to tangent, tangent doesn't have that because tangent does not use the hypotenuse. Tangent of angle A can be less than 1, it can be equal to 1, and it can be greater than 1. And here's a little trick with that. If the tangent of the angle is less than 1, that means that the angle itself is less than 45 degrees. If the tangent of the angle is equal to 1, that means that the angle is actually 45 degrees. And if the tangent of the angle is greater than 1, that means that the angle is greater than 45. So by looking at this problem, since the tangent of angle A is 2.4, which is greater than 1, then I know that A has to be greater than 45. Finding trig values for given angles. Tables of ratios for different angles are available, and most calculators have keys for the sine, cosine, and tangent. In previous examples, if we used a protractor to carefully measure angle A, we would find its measure to be approximately 67.3 degrees. Using a calculator, key in the given angle, or a table rounded to the angle to the nearest degree, we find that sine of 63.7 is 0.9225, cosine of 67.3 is 0.3859, and tangent of the angle is 2.3906. These are the same ratios we found in our example when we converted the fraction to a decimal. If you want to double check this with your calculator, what you can do is you got to make sure you're in the right mode. So for regular calculators, you're going to look under the mode button. Now, if you have a mode button, you might have to hit it more than once because you want to make sure that this label is underlined. Then hit enter, make sure it stays underlined. If you have a DEG button, you want to make sure that your screen either says DEG or has a D on your screen. And if you have a TI-83 or 84 calculator, you're going to hit mode, and you're going to make sure you go down to degree. Then make sure you hit enter, because if you don't, it's going to keep it in the wrong format. If you're in the wrong mode, you're going to get the wrong answer every single time.